What if our universe wasn't born alone? Just take a second and look at this. It captures a truly mind-bending idea, that entire universes could be quantum linked from the very moment they're created. It's a concept that really stretches the imagination, and that's exactly what we're going to unpack together.
So welcome to Entangled Origins. Today, we're diving deep into a pretty radical theory that kind of recasts the whole story of our universe. What if it didn't just pop into existence by itself, but was born as part of a connected pair, sharing some kind of mysterious link across all of cosmic time? All right, let's start with this truly daring idea. At the very heart of this are some physics models proposing that universes can be born fundamentally linked, sharing a hidden bond that could somehow persist across billions and billions of years. And that really brings us to the central question, doesn't it? What if the Big Bang wasn't just a moment of solitary creation, but more like a separation? A cosmic event where the echoes of a shared beginning are still quietly shaping the patterns we see in our universe today. Now, to get our heads around a concept this massive, we actually need to zoom in, way in. The seeds of this incredible cosmic theory, well, they're found in the famously strange and wonderful world of quantum mechanics. So the whole foundation for this is a real proven phenomenon called quantum entanglement. This is where two or more particles get so deeply linked that they basically act as a single system. And here's the mind-boggling part. It doesn't matter how far apart you pull them. A change in one is instantly reflected in the other.
You know, a simple way to think about it is like this. Imagine you have a pair of gloves. You put each one in a separate box and mail them to opposite ends of the galaxy. The second you open your box and see a left-handed glove, you know instantly that the other box has the right-handed one. That's the core idea of entanglement. It's an unbreakable, shared state, no matter the distance.
Okay, you with me? Because here's the grand leap. The theory we're talking about takes that exact principle and just blows it up to the most cosmic scale you can imagine. What if, instead of two tiny particles, it was two entire universes that were born entangled from a single point of origin? Now, a wild idea is one thing, but how could scientists ever possibly test something so radical? Well, that's where the hunt for evidence begins. They're literally searching for faint, cosmic echoes of this shared beginning.
And this isn't just philosophy, we're talking about a real scientific toolkit here. Researchers are poring over the faint heat left over from the Big Bang, that cosmic background radiation, looking for tiny little anomalies in temperature or strange patterns that might hint at some kind of outside influence. They're also using really complex information theory and models of cosmic inflation to hunt for these telltale signatures.
But, and this is a really important but, we have to approach this with a good dose of scientific humility. There's this powerful reminder that says, models are maps, not territory. These theories are our best shot at drawing a map of reality, but they're not reality itself. The search for hard evidence is still very much ongoing. You know, this whole thing is just a perfect illustration of how science really works. It's this constant balancing act, right? You have this big picture wonder on one side and rigorous, disciplined investigation on the other. Progress isn't just one big eureka moment. It's a slow, careful process of refining your ideas, testing them, and ruling out other explanations.
Okay, so this is all fascinating cosmic physics, for sure. But it kind of begs a bigger question. Why does a theory like this actually matter? What does it mean for us, right here, right now?
And this is where a really abstract scientific idea starts to carry some real philosophical weight. I mean, if our universe is fundamentally part of a connected pair, what does that imply about the nature of our own existence?
An idea this huge forces you to totally rethink some of our most basic concepts. All of a sudden, our understanding of cause and effect, the very nature of randomness, and even the unique identity of our own universe, it's all cast in a brand new light.
Ultimately, what a theory like this does is reframe our entire cosmic origin story. It swaps out an image of a lonely, isolated beginning with one that is fundamentally relational, suggesting that connection might just be woven into the very fabric of reality from its very first moment.
You know, beyond just this one theory, this whole exploration reveals something really profound about the wonder of science itself, about how it pushes us to ask bigger, bolder, and frankly, weirder questions.
See, science isn't just a big book of facts we already know. It's a process. It's about having the courage to put forward these daring ideas and then carefully test them. And whether this specific theory is ever confirmed or not,
Its real value is in how it stretches our thinking and fuels new questions and new paths for discovery.
So I'll leave you with this to think about. If the universe itself began not in isolation, but in connection, how might that change the way we see the world, and maybe even the connections we build within it?